Hey Calc students, today we are going to learn section 5.2, the mean value theorem. Sorry I can't be with you today. First you should be given a note sheet by the substitute, and then these notes correlate to what you're going to find on that note sheet. So the mean value theorem for derivatives says that between 2 points A and B on a differentiable curve, there's at least one tangent line parallel to the chord AB. So let's first look at the visual. If I look at some graph, something like that, okay? And let's just pick 2 points here and here, call those A and B. So it's saying there's a point where the tangent slope is parallel to this chord. So this point right here would be B, f of B. This point over here would be A, f of A. Okay, so where is that point that would make it parallel? So somewhere in between here, probably maybe right here. There we go. We could call that point C. And if we drew its tangent line at C, we would see that it is parallel to the chord of AB. So what you see here is that this relates the instantaneous rate of change, or the derivative, to average rate of change, better known as Algebra 1 slope. So f prime of C equals f of B minus f of A all over B minus A. So let's look at an example of how we can use the mean value theorem for derivatives and find that C value that we're looking for. So it says, show that f satisfies the mean value theorem on AB. Find the value of C in the open interval that satisfies where the derivative is going to equal the average rate of change. So that means we're going to have to do both. Find the derivative of this function and find the average rate of change, or the slope. So let's start with slope. Slope equals f of B minus f of A over B minus A. And since our function is x to the 2/3, our interval is from 0 to 1. That would give me 1 to the 2/3 minus 0 to the 2/3 all over 1 minus 0. So our slope here would just be 1. So that's the first part. That's the average rate of change. So average rate of change. So that's the right-hand side. Okay, well, let's take a look up here at the left-hand side, which is the derivative. Okay, so the derivative in terms of x, so if f of x equals x to the 2/3, f prime would equal 2/3 x to the negative 1/3, which is the same as 2 over 3x to the 1/3, or 2 over 3 cube root of x. So what we're looking for is, what is that c value, or the x value, that makes the slope and the derivative the same. So now we are going to set 1 equal to 2 over 3x to the 1/3. If we set them equal, we can solve and figure out what that x value is where these two attain the same value. So I'm going to multiply both sides by 3x to the 1/3, and I get 3x to the 1/3 equals 2. Divide both sides by 3. And to remove the 1/3 off of the x, we are going to cube both sides. So x equals 8 over 27. So the better question for this is, let's go, oops, sorry about that. Oh, come back. Trying to get this to change colors. Here we go. So what does x equals 8 over 27 mean? You tell me, what does 8 over 27 mean? Thoughts? Okay, well hopefully you're thinking at the point at x equals 8 over 27, the average rate of change and instantaneous rate of change are the same. So that's what we're looking for here when we are asked the question of, show that it satisfies the mean value theorem. You have to find that c value, which is an x value, in that interval where slope equals the derivative. All right, let's turn the page. The next topic for today is where a function is increasing and decreasing. Okay, and it says that a function is increasing on an interval if the derivative is positive, and that a function is decreasing on an interval if the derivative is negative. Okay, notice that these functions have to be continuous and differentiable. Something to point out here, that the function f is increasing because of the derivative. F is decreasing because of the derivative. Okay, so on what intervals is y equals x squared increasing? Where is it decreasing? Well, we know what y equals x squared looks like. Okay, but let's show using our new definition here. We know that if y equals x squared, that y prime is 2x. So if I graph that in red, y equals 2x looks like this. So when we're looking for increasing and decreasing, it says where the derivative is positive, meaning above the x-axis. Above x-axis. And below the x-axis when f prime is negative, so below x-axis. So I look at my graph in red here and I see that from negative infinity to 0, it's below the x-axis. From 0 to infinity, it's above. So let's answer the question. Where is the function increasing? So increasing. And we're going to say y equals x squared is increasing from 0 to infinity because f prime is greater than 0. Again, the function is increasing because the derivative is positive. Where is this function decreasing? Okay, y equals x squared is decreasing from negative infinity to 0 because f prime is negative. Okay, so just make sure that we're saying the function is increasing or decreasing because of the derivative. Okay, let's try again. So we have another example here. Where is the function increasing and decreasing? If this is a non-calculator question, we need to make sure that we can graph both the function and the derivative and use the support to find that. So if this was for the function, I wanted to get a quick sketch of the function. I know that the function f of x could factor to x times x squared minus 4, which would be x times x minus 2, x plus 2, which would give me x-intercepts at -2, 0, and 2. This is a cubic function with a positive leading coefficient, so end behavior is going to have to look something like that. So there's a quick sketch of the graph of the function. Now let's move to where is it increasing and decreasing. So let's find out where the derivative crosses the x-axis. So move on to f prime. F prime of x equals 3x squared minus 4. And if we want to set that equal to 0 to find the zeros of that function, 0 equals 3x squared minus 4. Move the 4 over, divide by 3, and square root both sides. So plus or minus 4/3 equals x. We could make that into a decimal or get a better idea. That would be 2 over root 3. And plus or minus 1.155 equals x. So if that was non-calculator, don't really need that, but just to give you an idea of the graph. So a little bit more than 1 here, have x-intercepts here and here. Now we know the graph of the derivative is going to be a quadratic, so it's going to look something like this. Okay. And remember that when we're looking for increasing and decreasing, where is the derivative above x-axis? Where is the derivative below x-axis? And remember, this is f prime, f prime. So let's make sure that we answer the question. Okay, so we would say y equals x cubed minus 4x is increasing. Where is it above the x-axis? Well, here is above the x-axis. So that would be negative infinity to negative root 4 over root 3 and positive root 4 over 3 to infinity, because f prime of x is positive. Okay, now let's answer for decreasing. We would say y equals x cubed minus 4x is decreasing, and that would be from negative root 4 over 3 to root 4 over 3, because f prime of x is less than 0. Uh-oh, come back. There we go. So, important to note, and I keep saying it, that the function is increasing or decreasing because of the derivative. We want to make sure that we get that clarified in our answer statement. Thanks for watching the video. You have some homework on your Google Calendar, and I will see you guys on Monday.